And just to give a really quick overview of the packed programming model, it's an extension of the MapReduce programming model. So basically, you can not only have one map and one reduce in a job, a processing job, but you can assemble whole data flows of operators, and you have a lot larger choice of operators than you have in MapReduce. Every operator is essentially a user-defined first-order function that is wrapped inside a second-order function that is provided by the framework. And the general idea here is that this second-order function, which is the green one here, it will do things to the input data so as to guarantee certain properties to the first-order function. So for the map operator or the map second-order function would guarantee that every tuple from the input data is given exactly once, or at least once to the first-order function. And for the reduce parts, we have sort of a modified, a different guarantee. The second-order function guarantees that it basically builds groups of the input data tuples by key. So it puts all the tuples with the same key into one set, and this set is then given to the first-order function. And the reduce part guarantees that this happens at least once, at least because there may be failures, so you may have to re-compute something else. Okay, so these are the map and reduce operators that you're probably familiar with from Hadoop MapReduce, but Facts also has others. So there's basically it adds binary operaters that take two input data sets. So there's a cross where you can construct all pairs of tuples from two input sets. There's a match, which works basically like an equi-join in SQL. So you can make pairs of tuples that have the same key. And there's a cogroup, which makes sets of tuples that have the same key. And these sets, these dotted sets here, are basically one invocation of the user-defined function, first-order function inside the package. All right, so it is such a package plan as we've seen here on this slide. This is a package plan. It is then put through an optimizer that assigns execution strategies. It can change the operator order. For example, it can push out some selection operations. And it basically constructs the execution plan, which uses the runtime operators. Runtime operators are essentially Java classes that run inside the natural data flow engine and provide some rule code to the framework for the first-order functions of the user. And all that is then executed on the natural data flow engine, which essentially takes this parallel instances of each task on cluster or cloud, and it will set up communication between the tasks and monitor the execution. All right, so I guess that's it for me now. So the whole system Stratosphere is started as a nationally funded research project in Germany, but it is available as open source. So there's this website, getstratosphere.com or stratosphere.eu, where you can download the software should be fairly easy to install, and also a lot of documentation on it, both on Acts and Qt. Okay, so thank you for your attention, and I guess we can ask questions now.
Thank you, Boyan. Now, if you want to have a question, Boyan, please. Okay. This is Mr. Hussein. We will ask you. Okay.
Hello.
Yeah. Hello.
About high and Meteor, can Meteor run standalone SQL query?
So the question is whether Stratosphere can execute a standalone SQL query. Did
Yes.
I get that?
Yes.
Okay. So right now we don't have a real SQL compatible front end, but there's a plan. There are plans to do that as future work to have to support a subset of SQL at least. So not all SQL operators are easily parallelizable on a cluster, but essentially we can. So there are plans to do things, the things that Hive does, for example. So you can write something that resembles SQL, which then is compiled down into a PAX program.
Okay, so no, there is an equivalent for Hive on Stratosphere?
Not to my knowledge, not at the moment, no. But so there's, I guess it's in the making, but it's not released, ready to be released yet.
Okay, thanks.
Any other questions?
Yes.
Okay, Boyan. Thank you. In the name of me and my faculty, we thank you about this wonderful presentation, and we hope to continue cooperation between Fayoum University in Egypt and TU Berlin Lima Group. Thank you very much, and if you can send me your presentation by mail.
Of course.
Okay.
Yeah.
And also, if you have any paper about Meteor or book about Meteor, if you have that.
Sorry?
If you have any paper also about Meteor. Brian? Hello? Yeah, can you hear me now?
Yeah, they can do that.
Yeah. I asked about if you have any paper about Meteor.
I'm sorry. I don't.
Any publication about Meteor?
Oh yes, there is.
Yes, if you can send me.
We can send you that.
Yeah, also is a presentation. Okay.
Yeah.
Okay.
Okay, sure.
Thank you for you, and special thanks for Professor Volkan Market. And we hope meet you here in Egypt soon.
Let's try it. At the end. Okay. Thank you very much for having me. It was a pleasure.
Thank you, Ian. Yeah. Goodbye.
Bye-bye.
Bye-bye. ترى بناخد تريد